Consider a point A having position vector OA with respect to origin O. Consider another point B having position vector OB with respect to origin O. AB is the line segment joining points A and B. Let R be a point that divides line segment AB. Point R can either lie between A and B and divide line segment AB internally, or can lie on extended line segment AB to divide AB externally. Let us find the position vector for R in both these cases. First, let us consider the case where point R divides line segment AB internally. Let vectors AB and R represent position vectors OA, OB, and OR for points AB and R, respectively. Let point R divide line segment AB in the ratio m:n. From triangle OAR, we get vector AR is equal to vector OR minus vector OA, which is equal to vector R minus vector A. Similarly, from triangle ORB, we get vector RB is equal to vector OB minus vector OR, which is equal to vector B minus vector R. Since the ratio AR is to RB is equal to m:n, we can say that m into vector RB is equal to n into vector AR. Let us substitute the values of vectors RB and AR in the equation. On simplification, we get vector R is equal to m into vector B plus n into vector A divided by m plus n. This expression gives the position vector of point R that divides line segment AB internally in the ratio m:n. Let us see what happens when point R bisects line segment AB. That is, point R lies at the midpoint of line segment AB. Here the ratio m:n is equal to 1:1. That is, m is equal to n. Putting m is equal to n in the formula for the position vector of R, we get vector OR is equal to the sum of vectors A and B divided by 2. Now, let us consider the case where point R divides line segment AB externally. Let vectors A, B, and R represent position vectors OA, OB, and OR for points A, B, and R, respectively. Let point R divide line segment AB externally such that the ratio AR is to BR is equal to m:n. From triangle OAR, we get vector AR is equal to vector OR minus vector OA, which is equal to vector R minus vector A. Similarly, from triangle OBR, we get vector BR is equal to vector OR minus vector OB, which is equal to vector R minus vector B. Since the ratio AR is to BR, is equal to m is to n. We can say that m into vector BR is equal to n into vector AR. Let us substitute the values of vectors BR and AR in the equation. On simplification, we get vector R is equal to m into vector B minus n into vector A divided by m minus n. This expression gives the position vector of point R that divides line segment AB externally in the ratio m is to n.